So we need to now calculate bond energies. Now, I just roughly do a quick diagram here because I wanted to explain how what are you actually doing. So when you want to calculate the overall energy change, remember endothermic was where sorry, when we were breaking bonds. So this is reactant and that is product, right? So when we break bonds, it's an endothermic reaction, okay? And when we make bonds, that's an exothermic reaction because endothermic takes in energy and exothermic releases energy, okay? So endothermic is a positive enthalpy change and exothermic is a negative enthalpy change, okay? So when you want to calculate the overall energy change, so like this bit here, you do energy in, take away energy out. So the energy that has been put into the system, so like by breaking bonds, take away the energy that has been given out from the system from forming new bonds. I hope that made sense, right? If you have any question, send me a message, okay? So overall energy change is always energy in, take away energy out, okay? So these are your reactants. So you are always breaking the bonds in the reactants, and these are your products. You're forming the bonds in the products, okay? So that's why you add up all the energies. So this is the inside, and this side is the out side. So here is where you put energy into the system, and here you the energy gets released out from the system. Okay, so let me then now show you one thing that you must always do. So I would strongly recommend that always draw a displayed formula. So draw your displayed structures before you do this calculation, because there's a very good chance that you could miss out a bond otherwise. Okay, so we have one hydrogen molecule. So this is our hydrogen molecule. And we know that hydrogen is only capable of making single bonds, all right? And we only have one chlorine molecule, so that's ClCl. So one chlorine molecule with two chlorine atoms. And here in our product side, we are making two HCl's. Okay, so we have one HCl and we have another HCl. Okay, so that's, I hope that's all clear. So we have one hydrogen molecule, we have one chlorine molecule, and we have two hydrogen chloride molecule. Okay, so look at the system. What are we breaking? So so energy in equals so we have one hydrogen molecule, and then we have one chlorine molecule basically. Okay, so you add them up, you shall get 9. Okay, 679. Okay, and don't forget the units, kilojoules per mole. Okay, and then next we have energy out. So by forming new bonds, this much energy was released out. So we have two of them. So 2 times 432, which would then be 864. Okay, so then the overall energy change is energy in, take away out. Okay, so in is 679 and out is 864. We have a negative answer, so it should be negative 185. And this time definitely write down your units. It's a good habit to write units here as well, but just making a quick video. So yeah, so negative 185 kilojoules per mole, and that's how you can deduce that it's exothermic, because exothermic reactions have a negative energy, okay, negative overall energy. Okay, I hope that all was okay, and I'll go through another example just to, it will be a good recap. Okay, I might do this one a bit more quickly maybe. So draw a displayed formula. So we have HBr and HBr, because we have two of them. And then, so let me also do this. So energy in equals, so we have two of them, so 2 times 366, that equals 732, right, kilojoules per mole. And then now energy out, so this is out, so we are making one hydrogen molecule and we're making one bromine molecule, right? So energy out, so we're making 1, 4, 3, 6 and 1 this one. So in total that one is, okay, I wrote the units in a different way, but they mean the same thing, right? Now energy change, so the overall energy change is in take away out, so 732 take away 629, and that should be a positive 103 kilojoules per mole. Okay, so since this is a positive energy change, so this was an endothermic, okay, endothermic reaction. I hope that's all good. If you have any question, do ask me, but definitely remember that draw displayed formula, because some of them might be easy, so you might get lazy to draw them out, but sometimes you may come across compounds where you can see things clearly. Like for example, if you have like C2H2, then you know that carbon is capable of making 4 bonds, but you only have 2 carbons there and 2 hydrogens. So that would mean each of them have 1 hydrogen molecule. So in that case, this carbon will have a triple bond. Okay, now I would think that is very rare for you to see that kind, but this kind might be more common for you to come across. Or nitrogen, so N2 has a triple bond. Okay, so be careful. So a nitrogen molecule has a triple bond, and then C2H4, again you have 2 carbon atoms, and then you have 4 hydrogen atoms. So we like to be as symmetrical as possible in chemistry, so that's how they are. So each carbon is capable of making 4 bonds. So if this carbon is busy with 2 bonds and this carbon is busy with 2 bonds, that means they each can make 2 extra bonds. So, and that's the reason why they will have a double bond between them, because carbon makes up to 4 bonds. 1, 2, 3, 4. It must have 4 bonds to become stable, right? So drawing this displayed formula shows you clearly how many bonds there are and what bonds there are, and then you can add or subtract your bond energies accordingly, right? Do not risk it, because this is very easy, especially if you're good in maths. This thing is a piece of cake, but only if you draw the displayed formula. Okay, otherwise there's a big risk that you might miss out 1 bond and you'll lose marks. So I hope you understand that clearly.